For concept activity 2, you'll be doing a worksheet that corresponds with a link that's found here. And this link goes to an applet that you'll use to discover things about the derivative of this function that we're given. Normally, whenever I do this activity, it's in class and people work with pairs and can use my feedback. So there are a couple of places that students tend to get confused about the applet. So I wanted to make a video to show you how it worked. This will be a two-part activity. So the second part of this concept will be given in the following week. So let's begin. So the first thing that you're asked to do is graph the function. And I've came up with a function that's similar to the one that's given on your activity, but it's a little bit different. So my function is f of x is equal to negative 3x cubed plus 5x. So what you'll do is you'll go to the applet, and whenever you pull it up, it'll actually graph the function x squared. You'll see that what you want to do is you want to graph your function in here where it says create your own f of x. I went ahead and typed my function that I'm using as an example here. So once you hit graph, you should get your own function. So now, it looks like the first thing you should do is rewrite f of x so it's the product of two functions. You'll notice that f of x has a x common in both terms. So we can factor out an x to rewrite f of x to be x times negative 3x squared, because I factored out an x, plus 5. Now f of x can be viewed as the product of two functions. So you'll notice that this f of x and this f of x are the same functions, just written a little bit differently. So now I want to find the derivative of f of x. I'm going to find the derivative by using two different rules. The first one, I'll use the power rule, so I'll refer back to the form negative 3x cubed plus 5x. So using the power rule, f prime of x is equal to negative 3 times 3, which is negative 9, x to the 3 minus 1, which is 2 power, plus 5. Now I want to find the derivative using the product rule. So to use the product rule, I'll use this form of f of x. And I can see that this is the product of two functions. X is my first function, and negative 3x squared plus 5 is my second function. So f prime of x is equal to the derivative of the first, which is 1, times my second function, plus the derivative of the second function. Let's see, negative 3 times 2, that's negative 6. X, 2 minus 1 is 1, so it's to the first power. And then the derivative of 5 is 0. So that's the derivative of the second function. I still need to multiply it by the first function. So you'll notice that both of these are f prime of x. What you should do before you continue is you should make sure that these functions are actually the same thing. Now let's get back to the app. It says click on the option, show the line to the f graph at x is equal to c. Change the value of c by moving it along the x-axis. Describe what is happening. So we'll go over to our app and we'll show the tangent line. Then you're going to move the c value so that you're changing the x value for which you are looking at the tangent line. what you'll do is you'll describe what you're seeing here. Pretty neat, huh? So you'll describe what's happening here. Approximately, what values or what x values do you have a horizontal tangent? Explain why. So you'll go back over to your app and you'll look for whenever the tangent line is horizontal. So it looks like for my function, it's horizontal maybe at x is equal to around 3/4. You'll be approximating this value here, for now at least. Let's see, is there another value for which the tangent line is horizontal? Oh, it looks like about right here. So maybe around -3/4 as well. Your function might have different values for x values, or c, for which you have a horizontal tangent. So then you'll explain where your horizontal tangents are. Next, click the option plot c, f prime of c. Describe the input and output of this point for different values of c. There we go. So I'll hit the button, click, and I'm gonna plot this point. You'll see that the point is plotted in red. So you'll play around with moving your c value and seeing what happens to this red point. For a hint, look at what you're actually plotting. The x value, or your input, is c, and your output value is f prime of c. Next, what you'll do is you'll fill out the table using the equations of f of x and f prime of x, and then you'll check your answers with the point c, f prime of c. So the first value I want to look at is when c, or x, is equal to -2. So I'm going to find f of -2, the output of my original function at -2. So, since my original function was -3x cubed plus 5x, I can plug in -2 to get -3 times -2 cubed plus 5 times -2. You can compute that value and then check on your graph to make sure that you have the correct output for the original function. And then we can find out what the output of the derivative at -2 by plugging in -2 into our derivative function, which is given as -9x squared plus 5. So f prime of -2 will be -9 times -2 squared plus 5. You can calculate this value and then go to your graph and see if when your input is at -2, the output of that red dot is equal to this value. The next thing that you'll do is you'll look to see when the red dot is above and below the x-axis. Why is that? So we'll go back to our function and we will see when the red dot, where is that red dot? Oh, it's below the x-axis now. Right there, it starts being above the x-axis. I think it's still above the x-axis. Yep, still above the x-axis, still above the x-axis. And then right here is where it starts going below the x-axis. So it looks like it's below the x-axis, greater than this c value, above the x-axis between this c value and this c value, and then it goes below the x-axis from negative infinity till about that c value. So what I want you to do is try to figure out what's the pattern. Do this with your function and see when you can tell when your c value is below the x-axis and when the c value is above the x-axis. What's happening with your original function? Next thing you'll do is write a couple sentences describing the geometric meaning of derivative. That is, what's the meaning of f prime of x. I think you should be able to do that without any more explanation. Next, you'll click the option Trace the red point. Change the c value, but by moving it along the x-axis. Describe what is happening. This is the cool part. So you'll click the button Trace the red point. How cool. For this response, some good things to talk about is, again, when the red dot is above the x-axis and when the red dot is below the x-axis. What would you get if you connected these red dots? What type of function are you looking at? Next, this is the graph of my function. So what I would do is I would sketch the derivative on this function. And then I'm going to look for the relationship between f of x and its derivative, f prime of x. In particular, I want you to fill out when f prime of x is equal to 0, when the derivative is equal to 0, that is whenever the derivative has a root, f of x does what? When your original function f of x is increasing, what is the derivative doing? F prime of x. When f of x is decreasing, what is your derivative doing? F prime of x. Using this, find where the function is increasing and or decreasing and the function's relative minimum and maximum algebraically. Does this make sense using the applet? So what I'll do is I'll go through calculating when your original function is increasing, solving it algebraically. You can see, using pre-calculus information, that your function is increasing on this interval. And that's between the values whenever your derivative was equal to 0. And also, the red point was above the x-axis between this interval. That's because the slopes of these tangent lines are all positive on this interval. So when f of x is increasing, your derivative is positive. When your original function is increasing, the slopes of the tangent lines are greater than 0, are positive. So if I wanted to solve for when your function f of x is increasing, I could set my derivative greater than 0 and solve. So what is our derivative? Our derivative was negative 9x squared plus 5. So negative 9x squared plus 5. I want to set that greater than 0. I want to solve for the x values that make that inequality true. So subtracting 5 from both sides, I get negative 9x squared is greater than negative 5. Then you divide both sides by a negative 9. Whenever you divide by a negative number, remember you switch the inequality. So you'll have x squared greater than 5/9. So x is greater than plus or minus the square root of 5/9. Now, that means x is between the negative square root of 5/9 and the positive square root of 5/9, which makes sense, right? According to where we estimated that your function was increasing. So this value should be exactly negative square root of 5/9, and this value should be exactly positive square root of 5/9. Enjoy doing this with your function, and I hope you learn a lot about derivatives and their graphs.